Hello and welcome to A-Level Math. Remember on Instagram I asked you that if you take two toothpicks and place them on a board and tie an elastic band and then stretch that elastic band and move it with a pen or pencil such that it's equally stretched throughout, then what is the shape that you're gonna get? So to know the answer, stay tuned. So the answer to that question is ellipse. So the ellipse is the same shape as you already know that the Earth's orbit is in. So what is an ellipse? So we have already discussed the definition in the very question that if you take 2 points and if you move those 2 points in such a way that, sorry, if you take 2 points and if you move another point in such a way that its distance from these 2 points, if you add these two distances, then it's always some constant, then the path that this point is going to trace will be an ellipse. All right, so this is the definition of an ellipse, but this is not the only definition. There is one more definition with which we will take things a step further, but for now let's see what's there in this video for you. So we'll be discussing about the definition of the ellipse in terms of its focus and directrix. So if you're familiar with the concepts of parabola, in parabola as well we had a focus and the directrix, but there we had just one focus and one directrix. An ellipse has two foci. Each of these points which are fixed are a focus. So there are two foci. So plural of focus is foci, and the plural of directrix is directrices. So we'll be discussing about the equation of the ellipse, the focus and its directrices, the derivation of the equation of the ellipse, and finally we will take up some solved problems on horizontal and vertical ellipses. So what are horizontal and vertical ellipses? You know that in parabola we had many types of parabola: upward facing parabola, left-handed parabola, downward facing parabola, and right-handed parabola. In a similar way, we have two types of ellipses. One looks like this and another one looks like this. So this is a horizontal ellipse and this is a vertical ellipse. So let's first of all try to figure out what the equation of an ellipse looks like. So I won't take much of your time in deriving the equation because it's not at all required from exam perspective. It's almost never asked in the examination, but still I'll quickly tell you how to determine it. So remember I told you that there are two ways in which you can find out the equation of ellipse. One is with the help of the definition that we covered over here and in the Instagram question as well, but the definition that we are going to use for this purpose is this definition. So let's understand the another definition of the ellipse. So this definition says that if you take a point and you move this point in such a way that its distance from another fixed point, which is effectively known as its focus, so its distance from this particular point and its distance from this particular line always maintains a constant ratio, which is known as eccentricity. All right, so this is the definition that we are going to use, that if a point moves in such a way that its distance from another fixed point and another fixed line always maintains a constant ratio, that means PS divided by PM is E, and this happens for all the points on the curve, then the curve traced out by this moving point is known as an ellipse. So let's quickly see how to determine this equation. So let's assume that this C is the center, which is 0 comma 0, and let's assume that this distance is a units. So these are the two assumptions that we make, that this is the center of the ellipse, which is known as which we take as 0 comma 0, and this distance CA, this distance is CA, we have assumed it to be a units. All right, so okay, now I told you that for any point on this ellipse, this distance PS by PM, or say for example if we take this point A, then the distance AS by AZ will be E. So the ratio of these distances, will be E. So AS by AZ will be equal to E. Similarly, if I take any other point on the ellipse, say for example A dash, then its distance from focus and directrix will maintain this ratio E as well. So similarly, A dash S by A dash Z is equal to E. So if you are having any confusion, let me repeat myself. So just now I said that if you take any 2 points on the ellipse, the ratio of the distances from the focus and the directrix maintains the ratio E. So if I take this as my point on the ellipse, then what is the distance from the focus? AS. And what is the distance from the directrix? It's AZ. So AS by AZ is equal to E units. And if I take A dash to be my point, then the distance from the focus is A dash S and the distance from the directrix is A dash Z. This ratio will also be E units. So let's quickly cross multiply to see what we get. We get SA is equal to E times AZ, and if I cross multiply here, I get SA dash is equal to E times A dash Z. Let's add these two equations and see what we get. So SA plus SA dash. So SA plus SA dash is nothing but AA dash, total distance from A to A dash. So A plus A dash is equal to E times, what is AZ plus A dash Z? AZ plus A dash Z. Okay, we cannot find out directly, but let me give you a hint. So what do we have to do? We have to always figure out and transfer everything in terms of A. So remember that I took this distance CA to be A units. So in all of these calculations, I will try to split this AZ in terms of A. So I can write this AZ as CZ minus CA. All my task is to somehow get this CA length somewhere. Alright, this is my final task. So I can write AZ as CZ minus CA because I have to have CA in my theory. So AZ can be written as CZ minus CA, and similarly I can write A dash Z. I can write A dash Z as A dash C plus CZ. So because CA dash and CA are at equal distance, so both of these are A units. So either I want to have CA somewhere in my calculation or I want to have CA dash in my calculation, because both of these are known quantities to me and I want to take everything down to whatever is known to me. So again, back to where I was. So A dash Z, I want to write it down as CA dash because it's A unit plus CZ. So I can write A dash Z as CA dash plus CZ. Now if you see, CA and CA dash are equal because both of these are A units. So this is A and this is also A. So both of these I can cancel out and I am left with CZ plus CZ, which gives me 2CZ. Alright. So CZ plus CZ gives me 2CZ. And A plus A dash, what is it? It's SA plus SA dash, I'm sorry. So SA plus SA dash is nothing but AA dash, right? So AA dash is equal to 2E times CZ. And what is AA dash? It is A plus A units because this distance is A, this distance is A. So A to A dash is 2A units. So I can replace 2A over here and I can write it as 2E times CZ. So I get CZ is equal to A by E units. Alright. So I have found out this distance CZ. And what was it, guys? This was the directrix. So I have found out the equation of directrix. How come? So if you know that this is the origin and this is the distance of a line which is parallel to the y-axis, which is at a distance of A by E units. So I know that if any line is parallel to the y-axis, its equation is of the form x is equal to k, and the k is actually the distance of this line from the origin. So I can write down the equation of directrix as x is equal to A by E. So these are the things that we have. Let me clean up the board a little for you. Now similarly guys, if I subtract these two equations, initially I added these and I found out the equation of the directrix. Now I want you to subtract these two equations, and you subtract this minus this for your convenience, because SA dash seems to be a little bigger than SA. So SA dash minus SA is equal to E times A dash Z minus AZ. Now I leave it to you as an exercise. As I have mentioned that all your task is to somehow reduce all of these in terms of CA and CA dash. Try doing that and see if you are getting the length of this CS. So your task is use this and use whatever trick you want to use of lengths. So do some addition and subtraction of lengths, and finally you will have to reach here that CS is equal to AE. In a similar way that we have found out CZ, now using this equation, somehow try to figure out that CS is equal to AE units. So once you are done with this, you will see that we have also found out the coordinates of the focus. So because its CS is the distance of this focus from the origin, so I have found out that my focus is AE comma 0. So these are the two main things that we have already found out guys. First one is the equation of the directrix, and second one is the coordinates of the focus. Now what we want to do, we want to find out the equation of this ellipse. For that, what I need to do, we have to take a random point on the ellipse, and I want to say that okay, this PS by PM is equal to E. So that is what the definition says, PS by PM is equal to E. Alright guys, so how do we do this? So P is known to us, X comma Y, S is known to us, but this PM is still not known to us. So we'll have to figure it out, and I'll help you again in this manner. PM is nothing but NZ, because it's a rectangle. So PM and NZ are actually equal. So what about this distance NZ guys? So NZ, if I split it in two parts, I can see that NZ, let me write it down. I can see that NZ can be written as NS plus S. Okay, or maybe we can write NZ in terms of CZ, because that's already known to us. NZ can be written as CZ minus CN. CZ minus CN. CZ we have already figured out. CZ is the distance of this directrix A by E. So this is A by E minus, what is CN guys? So if you see, the point is X comma Y. That means this perpendicular height is Y and this length is X, because in order to reach the point P, we need to travel X units in the X direction and Y units in the Y direction. So that means this distance CN is equal to X units and this height is Y units. So we have the length CN. So in this way we have got the value of NZ, which is also equal to PM. So NZ, in place of NZ I can write down PM, and then I can use this thing to find out the equation of the ellipse. So what I have is that PS by PM. What was PS? PS is the distance between X comma Y and AE comma 0. So you'll have to use the distance formula to find out PS, and PM is already known to us. Then what do? You do PS by PM is equal to E, and try to figure out whether you are getting the equation as X square by A square plus Y square by A square times 1 minus E square is equal to 1. Verify and let me know in the comment section if you are getting this same equation or not. If you are not, then you can mail your doubts to me at a_level_math@yahoo.com. Alright guys, let's take our discussion a step further. We assume that this distance A square times 1 minus E square, we let it to be B square. So B square I can write as B square is equal to A square times 1 minus E square. We just assume for simplicity. Alright. Now our equation reduces to a much nicer form, which I can write as X square by A square plus Y square by B square is equal to 1. Now this is the equation of a horizontal ellipse guys. Now what is a horizontal ellipse, we'll understand in a bit further when I deal with my vertical ellipses as well. But for now, what takeaways you have at this point are that A has to be greater than B and E has to be always less than 1. These are the two key takeaways that you need to have, and we'll soon understand why is this the case. So so let's not get into much of the theory now, and let's take up a practical question to understand the question a bit further. So let's take up the question. Find the equation of the ellipse whose ends of whose major and minor axes are the ends of whose major axes are plus minus 3 comma 0 and 0 comma plus minus 2. All right, so we are given the equation. We have to find out the equation of the ellipse, the ends of whose major axis are plus minus 2, and these are the end points of minor axis, guys. I'm sorry that there is a miss in the question. Plus minus 3 are the ends of major axis, and 0 comma plus minus 2 are the ends of the minor axis. So let me quickly tell you what major and minor axes are. So if you take this and this as your ellipse, now this, remember, there was a point C and there was a point A and there was a point A dash. So we said that we assume this distance CA to be equal to A units. These 2 points A and A dash are known as the vertices of the ellipse. So that means there are two vertices. First one is A comma 0, second one is minus A comma 0. All right, so this total length is known as the length of the major axis, and this is known as the major axis, guys. So A dash is a part of the major axis. The entire axis is known as the major axis. So A dash is actually a part of the major axis. I have made it a little dirty, but okay, bear with me. So, and what is minor axis, guys? Minor axis, in a similar way, if I take these 2 points, these are 0 comma B and 0 comma minus B. So these are my end points of the minor axis. The length of the minor axis is 2b units because b plus b is 2b units. And yeah, minor axis is along the y-axis. So always remember that for a horizontal ellipse, which we are dealing with as of now, for a horizontal ellipse, major axis is along the x-axis and minor axis is along the y-axis. This is the key difference that will help you understand whether an ellipse is horizontal or vertical, and things will change a little bit different for vertical ellipses and for horizontal ellipses. Things will be a little different, so don't worry about it now. We'll understand what the differences are, but bear with me for the time being. So we are given that the major axis is plus minus 3 comma 0 and minor axis ends are 0 comma plus minus 2. So if I compare with this equation, these coordinates with plus minus a comma 0, which are the endpoints of my vertices, guys, because a comma 0 and minus a comma 0 I can write down as plus minus a comma 0 as the endpoints of my vertices. So if I compare plus minus a comma 0 with plus minus 3 comma 0, I can easily find out the value of a, which is 3. And if I compare 0 comma plus minus 2 with my endpoints of minor axis, which are 0 comma plus minus b, then I quickly get the value of b, which is equal to 2. I have the value of a, I have the value of b, so I can easily write down the equation x square by a square plus y square by b square is equal to 1. So just plug in the values of a and b and you will be getting the equation of your ellipse. So x squared by 9 plus y squared by 4 is equal to 1. And remember, guys, what I was telling you a few minutes ago, that for a horizontal ellipse and even for a vertical ellipse as well, these are the things that are always going to be: a is greater than b and e is always less than 1. You have to always remember this thing, guys. A will always be greater than b and e will always be less than 1. If you look closely at this formula that we have, b square is equal to a square times 1 minus e square. If you take e to be less than 1, then this quantity becomes a proper fraction, and if you multiply anything with a proper fraction, it reduces its value. So 1 minus e square when multiplied to a square reduces the value of a square. That is why b square is always less than a square. So if b square is less than a square, then b should be less than a, I'm sorry, or equivalently A is greater than B. So always remember, for any type of ellipse, we always have A to be greater than B and E to be less than 1. These are the key takeaways for now. We expand our concepts as we move ahead. But for now, let's have a quick uh, recapitulation of whatever we have discussed so far. So let me quickly draw an ellipse. This is my ellipse. If I draw the major and the minor axis, then guys, this is the center which we have taken to be the origin. I have taken these to be my vertices, which are plus a comma 0 and minus a comma 0. These are my two foci. Remember that this CS distance was AE. So I have got two foci. One is at AE comma 0 and another one is at minus AE comma 0. The length of the major axis, this is the length of the major axis, and it was A plus A, which was 2A units. The length of my minor axis was B plus B, which was my 2B units. The equation of the major axis, because major axis is along the x-axis and the equation of x-axis is y is equal to 0, and the equation of minor axis will be, because the minor axis is along the y-axis, its equation is x is equal to 0. The length of the latus rectum, remember from the parabola that if I have a if I take the focus and if I draw a perpendicular to the major axis from this focus, then this distance is known as the latus rectum. This particular length is known as the latus rectum, and we have to find out its distance. For now, take my word for granted that this distance is going to be 2b square by a, but bear with me, I'll just in a few minutes derive the length of this latus rectum. Just understand this. And eccentricity is E. Don't get bogged down with this formula, you can safely ignore it. Just remember that E is known as the eccentricity, which is the ratio of PS by PM, where P is any point on the ellipse and S is the focus and PM is the distance of P from the directrix. So this ratio is always constant, is less than 1, and is known as eccentricity. This is the key takeaway, that eccentricity has to be always less than 1 and A always has to be greater than B. These are the two key takeaways, and all these things you try to remember and memorize. Let's quickly find out the length of the latus rectum. So let's draw an ellipse. So if I draw the major and the minor axis, then this becomes my focus, which is AE, and this is my latus rectum. Let us assume that my latus rectum, so let us assume that this point is H comma K. Alright, so that means this distance is H and this distance is K, but we already know that it's not actually H, it's just AE. This distance is AE and this K is not known to us, right? So I can replace this point as AE comma K. Why so? Because I know that this distance is AE units and this distance is K units. So because it's passing through focus, so I can replace H by AE. Okay, now I know that this AE comma K lies on the ellipse. So x square by a square plus y square by b square is equal to 1. If you plug in these AE comma K into this equation, then you will be getting a square e square by a square plus k square by b square is equal to 1. And if you solve, you will get that the value of k turns out to be b square by a. So this length, guys, what was k? K is this perpendicular length. So this is the focus, then k is this perpendicular length. So half this part turns out to be b square by a, and similarly this downward part will also turn out to be b square by a. So the total distance is b square by a plus b square by a. So the length of the latus rectum turns out to be 2b square by a. Pause the video and verify whether you are getting this result or not, and let me know in the comment section or by mailing it to me. So let's quickly take up another question. Find the equation of the ellipse whose center lies at the major axis. The eccentricity is 2 by 3 and the length of the latus rectum is 5 units. Now this information, guys, that the major axis lies on the x-axis, you might see that this is not required as of now, but this will be required when we talk about vertical ellipses. So because for now there is only one kind of ellipse that exists, so this you might see that this information is not making any sense to you, but it will, bear with me. So okay, let's quickly jot down whatever we have at hand. E is equal to 2 by 3 and just verify that it is less than 1, so we are good so far. Length of the latus rectum is 5 units. What was the length of the latus rectum, guys? Just now we have derived the length of the latus rectum is 2b square by a, and it's 5 units. So these are the two things that are given in the question. Also, we know that b square is a square times 1 minus e square. This you always have to keep in mind, because this interchange you'll have to keep on doing. All right, guys. So just plug in the value of e over here, and you can figure out what b square is. So from here I get 2b square is equal to 5a, or b square is equal to 5a by 2. Just plug in b square as 5a by 2 over here and plug in the value of e. So b square is 5a by 2 is equal to a square. 1 minus e square is 4 by 9. Simplify and see what you get as your a. So when you get your a, just again put down the value of a and e, or maybe you can use this equation. Then just use a to figure out the value of b square, and from here try to figure out the value of b. And guys, once you have the value of a and b, equation of the ellipse is no brainer. It's just x square by a square plus y square by b square is equal to 1, and then that's how that you determine the equation of the ellipse. Let's quickly take up another question, and this one is the exact opposite of what we have discussed as of now. So as of now, we were given some information about the ellipse and we were asked to derive its equation. Now it's just the reverse, in that we are given the ellipse, the equation of the ellipse, and we have to find out everything about it. So let's quickly write this down in our standard form. So it's 4x square plus 9y square is equal to 144. If I divide throughout by 144, because I need to have a 1 on the right hand side. Remember, x squared by a squared plus y squared by b squared is equal to 1. So I need to have a 1. So I divide everywhere by 144. So 4x square by 144 plus 9y square by 144 is equal to 1. Now I need not have anything to the left of x square. So what I do is that I write this 4 down here, and similarly I write this 9 down here. So I get my a as 144 by 4, sorry, a square, and my b square as 144 by 9. So from here I get the value of a square and b square. A square is 144 by 4, which gives me a is equal to 12 by 2, which is equal to 6. B square is equal to 144 by 9, which gives me b is equal to 12 by 3 is equal to 4. Alright guys, so I have got the value of a and b, and I can quickly use these values to find out e square using my formula. B square is equal to a square into 1 minus e square. I leave this to you as an exercise to find out the value of e. And let me quickly tell you what to do next when you have all these values. So you have a, you have b, you have e. Now what you need to do, you have to find out the lengths of the major and minor axis. The length of the major axis is, remember, 2a units. Minor axis will be 2b units. So a is 6, so major axis is 12 units. B is 4, so minor axis is 8 units. And this is 12 units. The coordinates of the vertices, remember what the coordinates of vertices? Plus minus a comma 0. So in our case it is plus minus 6 comma 0, and the foci are plus minus a e comma 0. I don't know what the value of e is, but whatever it is, just plug in these two values, a times e and plus minus a e comma 0 will be your answer. Eccentricity you will find out. Length of the latus rectum is 2b square by a. So 2, what is b square? 4 square by a is 6. So you can cancel things out over here. 2 times 3 is 6. So 16 by 3 is the length of your latus rectum. And the equation of the directrix, remember, it's x is equal to plus minus a by e, because we have two directrices, guys. So first we have a focus over here and a directrix over here, and then we have a focus, another focus over here and another directrix over here. So this directrix is x is equal to plus a by e, and this directrix is x is equal to minus a by e. So these are the concepts of a horizontal ellipse. Now let's move forward to discuss vertical ellipse. Okay, let me delete these things. All right, so vertical ellipse is just the exact opposite of horizontal ellipse, in that it's just rotated by an angle of 90 degree. You can think of it that way. So all the points will shift. If my original vertices were plus minus a comma 0, it will be now 0 comma a and 0 comma minus a. Remember that the distance has not changed. The distance is still a units. It's just that we have rotated it by an angle of 90 degrees. So this point has now become 0 comma a instead of a comma 0, because it's on the y-axis, and this point is now 0 comma minus a, because in the same way it's on the y-axis, it's not on the x-axis. So similarly, my minor axis becomes b comma 0 and minus b comma 0. Now always remember, because the major axis is always greater than the minor axis, so because now this is our major axis and this is our minor axis, always remember bigger one is the major axis, smaller one is the minor axis. So always, because my major axis is 2a units and minor axis is 2b units, a is always greater than b. Doesn't matter whether it's an horizontal ellipse or a vertical ellipse, my a is always greater than b. That is why e always has to be less than 1, because of this formula, b square is equal to a square times 1 minus e square. If we always take a to be greater than b, then my e has to be less than 1. These two things just go side by side, hand in hand. Okay guys, so these are the concepts of vertical ellipse. Every coordinates will change. So my focus will be now what? Can you guess? Yes, it will be 0 comma ae, and this point will be 0 comma minus ae, and my directrices initially what they were x is equal to a by e, right? But now they are parallel to the x-axis, so this will be y is equal to a by e, and this directrix somewhere over here will be y is equal to minus a by e. So let's quickly see what are the facts and try to recapitulate whatever are the facts for the vertical ellipse. The center still remains at 0 comma 0. Vertices are now on the up and down side, so 0 comma a and 0 comma minus a. Foci are 0 comma ae and 0 comma minus ae. The length of the major axis is still 2a. The length of the major axis doesn't change. Major axis always is the bigger ones, minor axis is the smaller one, so minor axis is 2b. Equation of major axis is now along the y-axis, and the equation of y-axis is x is equal to 0. Equation of the minor axis is along the x-axis, and the equation of x-axis is y is equal to 0. Length of the latus rectum doesn't change, it's still 2b square by a, and eccentricity is e. Alright guys, so what are the key takeaways again here are that a is greater than b and e is less than 1. Always remember these two cases. Now you will understand why I'm time and again focusing on this fact so much. So again, you are given some equation and you are asked to find out all of the features, vertices, foci, eccentricity, blah blah blah. So our first task is to find out the to write down the equation in its standard form. This you always have to do. So because I have to get a 1 on the right hand side, so I divide by 100 throughout. So I'll be getting a 1 on the right hand side, and then to free up x square over here, I take it down here, and 100 by 4 I can write as at 25. I'm so sorry because I'm doing it this way, but I'm too lazy to write down everything time and again. Sorry guys. So x square by a square, so my a square is 25. And now you will have to make a proper decision. Alright guys, so now in the examination you won't be given, okay, this is a horizontal ellipse or this is a vertical ellipse. You'll have to figure it out on your own, that whether it's a horizontal ellipse or a vertical ellipse. So how to figure it out? Always see what's there in the denominator. For the x square we have in the denominator 25, and in the y square we have denominator to be 100. And I already told you that whatever is the bigger, we always take that to be as our a. So now my equation will be x square by b square plus y square by a square is equal to 1, because we always have to take a to be our greater than b. So we have a square to be equal to 100. This gives us a is equal to 10, and b square is equal to 25 gives b is equal to 5. I'm directly writing it down. So why am I doing it? Because I told you that always a has to be greater than b. That's why I take 100 as my a square and 25 as my b square. And then from the previous formula, I have already told you what are the different coordinates for vertices, major axis, minor axis. You can just refer to that, and I'll quickly tell you. So the length of major axis is 2a units, which is 20, because a is 10. Minor axis is 2b units, which is 2 times 5, 10 units. Coordinates of vertices, now because they are on the up and down part, so it's 0 comma a and 0 comma minus a, so it's 0 comma plus minus a. So 0 comma plus minus 10 are the coordinates of vertices. Eccentricity we have to find out, guys. E we have to find out by using the formula that 1 minus e square multiplied by a square gives me b square. So b square is equal to a square times 1 minus e square. Put on the value of b, put on the value of a, and try to figure out what the value of e is. And then foci is 0 comma plus minus ae. So these are the equation of my foci. Length of the latus rectum is still 2b square by a. There is no change in that. And the equation of directrix is, now this one is y is equal to a by e, and here it's y is equal to minus a by e. So you will always get this formula from this page. You can look into this. Equation of directrix is not written, I think, but otherwise everything remains the same. 2b square by a is the length of the latus rectum, eccentricity is e, and so on and so forth, focus and all. Okay guys, let's see if we have another question to take. Yep, find the equation of the ellipse whose vertices are at plus minus 5 comma 0 and foci are at plus minus 4 comma 0. So because vertices are given to be vertices are at plus minus 5 comma 0, so 5 comma 0 lies over here, minus 5 comma 0 lies over here. So it's clear that my ellipse in this case is a horizontal ellipse, guys, not a vertical ellipse, because my vertices tell me that my major axis is along the x-axis. That's why this is how you'll have to determine based on the coordinates that okay, my ellipse is a vertical ellipse or a horizontal ellipse, and then you can go ahead and write down the equation. Alright guys, so if it is a horizontal ellipse, the equation is going to be x square by a square plus y square by b square is equal to 1. Had it been a vertical ellipse, it would have been x square by b square plus y square by a square is equal to 1. Remember that a always has to be greater than b. Doesn't matter if it is a vertical ellipse or horizontal ellipse, and e always has to be less than 1. Doesn't matter vertical or a horizontal ellipse. Now foci is at plus minus 4 comma 0, so it's over here and here. So remember that foci are plus minus ae comma 0. So if I compare these, I get my a to be equal to 5 units, my AE to be equal to 4 units. So if I have A, I have AE, I can use this equation b square is equal to a square into 1 minus e square to figure out what is the value of my b. So if I multiply this throughout, I get b square is equal to a square minus a square e square. A square will be 25. AE is 4. So if I square both the sides, I get a square e square as 16. 25 minus 16 is 9. So I get the value of b square as 9. So I get the value of b to be equal to 3. And now because my ellipse is horizontal, so my equation will be x square by a square, which is 25, plus y square by b square, which is 9, is equal to 1. So this is the final equation of my ellipse, guys. So thanks a lot. I think this is the end of the video. Study hard and study smart with A-level math, and always remember that you can mail me any of your doubts at a_level_math@yahoo.com. Study hard, study smart. Bye bye guys.